last point of the speed measurement is your uh, contactless type of speed measurement. Now, how this contactless type of speed measurement we people are using? So here in this one, all the cases we people were trying. Suppose this is the shaft. This is the shaft, and when it is coming across uh, the shaft, means this particular device is directly connected to shaft. This one is contact type of transducer. Whereas in non-contact type of transducer or non-contact type of speed measuring device, suppose this is my rotor, and here I am using the device to capture the input of this particular rotation. So this one is continuously rotating, and based upon its rotation, here we people are going to get the output. Means this particular transducer is going to capture the output. So what significance or what technology has been incorporated so that the resultant output can be measured? Okay, that we are going to see thoroughly. So we have already gone through the contents, what we are interested to study in the previous lecture. So the objective of this particular lecture, or after completion of this lecture, you people will be able to understand the concept of contactless or non-contact type of speed measurement. So there are different type of non-contact type of speed measurement. So what they are going to measure, that the mean for the measurement without coming in contact is inductive type of transducer, then capacitive type of transducer, and one more, as you people are well aware with inductive, that is flux linkage, or capacitive, that is a change in capacitance based upon the various parameters. And last one is the stroboscope. It is associated with the frequency. That is interesting topic that we people are going to study. So you will be able to explain and elaborate how the speed can be measured uh, uh, using non-contact type of transducer, and its basic working principle can be understood, and you will be able to represent by your own. So as I have specified that speed is nothing but it is the ratio of distance by time. Now what distance it is covering? It is covering the angular distance, and that angular distance divided by time is called as a speed, or this is a general definition. Commonly we people have utilized it for all the three parts. So the last point that we are going to discuss is your contactless electrical type of tachometer. This means it is using the concept of electrical mean to measure the resultant output, because in electrical one, either you people are going to get the output in terms of current, or either you people are going to get the output in terms of voltage. However, the transducer or the sensor to measure that electrical output used is non-contact type, or it will not be in contact with that device. Okay. So first one is inductive type of pickup transducer. Now how this inductive type of pickup transducer is used? So suppose I am having the device. Suppose we people are having a device. Now what is going to happen? Inductive type is based upon the mutual inductance or the flux linkage. It is based upon the mutual inductance or the flux linkage. How that flux linkage takes place? Suppose I am having one plate over here, and the another one is this one. So these are the two plates. Secondly, I am having the second plate at this particular position, but the second plate is at this one. Now, here, if you try to check the distance between these two, if you try to check the distance between these two, this distance is small d and this particular distance is capital T. If I have specified it as a capital D, definitely my capital D is greater than that of small d. It means the distance between these two means or these two means are not same, not same. Suppose if I am interested to link the magnetic flux between these two. So in which one you people will get the maximum flux? In which particular one you people are going to get the maximum flux? Definitely the maximum flux linkage will be across this part, will be across this particular part. That is, small d consists of a small d will have higher flux linkage, higher flux linkage. This will have flux linkage compared to that of capital D. This will have less flux linkage based upon the distance, based upon the distance. So the similar concept actually is used for the measurement of inductive type of pickup transducer. How it is used for inductive type of pickup transducer? So over here, we people are having some slots. We are having here. If suppose this one is the structure, this is the structure, here is the crest, here is the stone, and across this one, if you try to visualize this particular part, here you are actually, here you people are having a coil of a permanent magnet, which will try to generate the output train pulses. Output train pulses. So here I am going to get the output. Here I am going to get the output. And this particular part is rotating one. So what happens? This part will, when this part is across this magnetic permanent coil, at that time flux linkage, that is phi, will be high. But if suppose this particular part, if suppose this particular part is, will show it, if suppose here is the, if this particular part is across this one, means if you try to measure the distance between this part and this one, now this is capital D, this one is capital D, and when it is moving towards the downside, because this one is rotating, if you see whatever I have drawn, that part is nothing but this crest, and this part, this lower part is nothing but it is between this one, it is between this particular part. So over here you people are going to get the resultant output. So working principle is very simple. The working principle is very simple. How it works? This one is ferromagnetic gear. This particular part is ferromagnetic gear, which is connected to the shaft, which is connected to the shaft. Now this shaft is continuously rotating. Is continuously rotating. Depending on these tips will also rotate. Depending on these tips will also rotate. So what is going to happen? The flux linkage between your this N and this tips will also continuously vary. That will also vary. So over here, when the distance, when these particular parts are across each other, that is small d, it will generate the high output. High output. And when it is nearby capital D, at that time it will generate low output. So this output will be for capital D and this output will be for capital small d. Likewise, train of pulses are generated. Train of pulses are generated. So you people can easily measure the resultant output. Okay, the resultant output can be generated. So coil wounded on a permanent magnet, not on iron core. Permanent magnet, it is wounded, means the coil is mounted on the permanent magnet but not on the iron core. This configuration enables us to measure a rotational speed of the system. In the construction of variable reluctance sensor, here ferromagnetic gear wheels are used and these gear wheels are rotating because they are connected to the shaft. So change in the magnetic flux takes place in the pickup coil, which further induce a voltage. That pulses which are generated, that particular pulses are nothing but these are the pulses that are generated. So these pulses are nothing but this is the output voltage that has been generated, and this output voltage can be measured, or this output voltage can be converted in terms of your speed measurement. So if you are increasing the speed of this ferromagnetic gear, at that time number of pulses which is going to be generated, that number of pulses will be much more. This number of pulses will be more in number because speed has been increased. If it has been decreased, at that time number of pulses generated will be less number of pulses. So you can directly convert that one in terms of speed. All the figures are similar to each other. Only the difference is that it utilizes the sense of magnetic uh, field or your magnetic pickup based upon the inductive nature. Okay. So here, actually, if you try to visualize at this particular instant, you people will. Between this one, you are having less. But as soon as these points are connected to this one, it is going to generate the high pulses. So suppose T is nothing but number of teeth that has been generated. So these are the teeth. These are the teeth. Okay, the 1, 2, 3, 4, 5, 6, 7. These are the number of teeth on rotor. N is revolution speed, means how many times it is generating the speed. So when it comes across, the train of pulses are generated. So the formula for speed measurement, speed is given by your N, pulses per second, and number of teeth. So N is equal to P. P is number of pulses that are this, and T is nothing but it is number of teeth that are present over here. So P, that is number of pulses generated, divided by number of teeth present on that particular rotating body. Suppose you are interested to measure it in terms of RPM, that is revolution per minute. The upper one is for the second. So it will be given as number of pulses per second divided by number of teeth on the rotor multiplied by 60 seconds